After understanding the gaseous state, now let us move to the liquid state. See, it's a state of the matter in which what we find is the intermolecular forces are much more stronger than what we have in case of the liquid state. Molecules are more closer, very much closer to each other. There is hardly any space between them. But yes, they are free to move. And that makes this state to have what? The fixed volume, but no definite shape. The volume is fixed, but it takes the shape of whatever the vessel or in whatever the container we put this liquid in. So no fixed shape, but fixed volume. Stronger intermolecular forces, very less intermolecular spaces, but molecules are free to move in that particular space. Now, this liquid state is characterized by certain very specific properties which are very, very important and fundamental to us. One of such properties of the liquid state is their property called vapor pressure. See, if we take any liquid, let's take an example of water in a beaker. What we find is after some time its molecules comes into the gaseous state. So this is water liquid, this is water gas. If this vessel is kept open, they will be moving out, and we say the process of evaporation is going on. And if we closes this, what we find is after some time these vapors, they come in contact with this, which are in contact with the liquid state, they develop an equilibrium with its liquid state. Now when they develop an equilibrium between this liquid state, how they develop equilibrium? See, the three sides are glasses. So the molecules which will be going down, which will be striking the liquid state, will become the part of the bulk. They will not be coming back. But similarly, there will be a lot of molecules on the surface which will be having very high kinetic energy, so they gets converted into the gaseous state. So this conversion of going back to the liquid state and getting converted into the gaseous state is keep on happening together, and that is why what happens is after some time the two states attains equilibrium. Equilibrium means the amount of this water vapors will become same, becomes constant. It doesn't changes with time then. Now at that temp system, when the equilibrium is established, if you attach as a manometer here, you can easily measure the pressure exerted by these vapors, because they will push this mercury down. This will go up, and you can easily measure the pressure exerted by these vapors. Now this pressure, which has now been exerted by these water vapors, is called vapor pressure. So what is vapor pressure is? Vapor pressure is the pressure exerted by the vapors of a liquid present in equilibrium with its liquid state at a particular temperature. See, this vapor pressure is directly depending on our temperature of the surroundings. So that's at a particular temperature which we are keeping it as a constant. Whatever the pressure is exerted by this vapors which are in equilibrium with this liquid state is called the liquid's vapor pressure. Now this vapor pressure gives us a very valuable information. When this vapor pressure is the one which becomes equal to the atmospheric pressure, the liquid starts boiling. So you need to know another thing which is the boiling point. So what is boiling point of a liquid is? It is the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure. Like suppose, let's take an example of water. For water we know that if the temperature is, the pressure is 1 atm, water boils at 100 degrees Celsius or 373 Kelvin. We call it normal boiling point. If the the pressure is, outside pressure is 1 bar, we call it what temperature to be, the temperature comes out to be 372.6 because it becomes 99.6 degrees Celsius, and this is Kelvin, and this is called normal, we call it normal boiling point. So that's the differences, but what you need to know is this is how the liquid boils, because at this particular temperature, the vapor pressure exerted by the vapors of that particular liquid like water becomes equal to the atmospheric pressure. And that is why in order to do quicker cooking, we use this pressure cookers, because when we close them, we actually are confining those vapors in there only, which increases further the vapor pressure. So the vapor pressure applied on the water which is there for cooking of any food gets increased, and once that increased, the temperature of boiling point, temperature of boiling or the boiling point also gets increased. So the same food actually is experiencing much higher temperature, so it can be cooked very easily, or it gets cooked easily. Now this 372.6 is called its normal boiling point, and this is how we understand the vapor pressure and in the boiling point. Now what you need to understand is that the same boiling point phenomena is the one which is being used in the case of the pressure cookers. In pressure cookers, when it increases, what happens is the lid is always kept closed. So whatever the vapors are being created, they are the ones again which are putting up more pressure on the boiling liquid. So that is why the boiling liquid is experiencing a much higher pressure. So the boiling point of that water, or the water, is also gets increased. So the same food which is being cooked in that boiling water is experiencing a much higher temperature, and that is why it gets cooked fast, or cooked actually much quicker than what it should be at a normal condition, normal temperature, or normal boiling point. So that is what is the use of the pressure cooker is, and that is why it is recommended that in hilly areas and high altitude places we must use pressure cookers, because there already the pressure is very low. So what will happen is, of course, the boiling point will be less, but the food which is requiring the very high temperature to get cooked will not be able to experience that high temperature. So that is why you feel difficulty in cooking, the cooking becomes difficult at a high altitude places. So that is what is the basic phenomena which are behind this vapor pressure and its use in the different day-to-day life.